So what I'd like to do now is just kind of work through one of the practice problems you had. So this is the first one. It says there's a first class lever in static equilibrium, and it has a 50-pound resistance force and a 15-pound effort force. The lever's effort force is located 4 feet from the fulcrum. So I'm supposed to sketch and label the system. So what I'm going to do is I've just kind of already brought some components in, and I'm going to arrange them and show them to you. So I have some kind of lever here, and I'll go ahead and get it set up. Alright, and I have a 50-pound resistance force. Okay, so resistance force is the load. Alright, so my load is sitting here. I'll put it right there, and it weighs 50 pounds. Okay, then I have an effort force, right, being applied to the lever, and I'll just slide it down just a little. So I'm putting it on the other end of the lever, alright, and I'm using an effort force of 15 pounds, alright. And then I say here in the problem, the lever's effort force is located 4 feet from the fulcrum. Remember, the effort force is what I do, so I'm just going to drag this one up here so you can see that's 4 feet. Alright, so what I don't know is this distance. Okay, so really, when I think about this, as I started to think about it, you need less effort than the resistance. So this arm must be longer. Okay, and here at the bottom I kind of have that little graphic that's on your handout. The effort force times the effort distance is equal to the resistance force times the resistance distance. Okay, so this would kind of be my sketch and label the system. What I don't really know is this resistance distance, so I'll type in a little dr for that, because I don't really know that number, right? That one's kind of missing, right? And what is the actual mechanical advantage of the system? It says here, the actual mechanical advantage is determined by the ratio of the forces. All right, so to calculate the actual mechanical advantage, all right, what we would do is we would take the ratio of the resistance force divided by the effort force. All right, so let's type that in. AMA is equal to FR divided by FE. All right, and that's going to be equal to what? 50 pounds divided by 15 pounds, and that's going to be equal to, I don't have a calculator on me, that was poor planning, wasn't it? 10 divided by 3, so that's going to be 3.33. And remember that mechanical advantage is unitless, so I think I did that math correctly. So that's going to be the actual mechanical advantage. Alright, so now I've got the first bullet done and the second bullet done, so that seems pretty good. And now I want to say, what is the distance from the fulcrum to the resistance force? Oh, so I've got to use another formula. What am I going to do? I'm going to use the one from the graphic in your handout. Alright, effort force times effort distance is equal to resistance force times resistance distance, because I know effort force is 15 pounds. I know effort distance is 4 pounds. I know the resistance force. Okay, I don't know the resistance distance, so I can solve for it. Alright, and I'm going to abbreviate those and type them here in a second. Alright, so let me just get a little text box here to type with, and alright, so I know that the effort force times the effort distance is equal to the resistance force times the resistance distance, right? So that's going to be 15 pounds times 4 feet is going to be equal to 50 pounds times, oops, I left my pounds off, times dr. I don't know dr yet. So when I rearrange that, to get dr by itself, I need to divide both sides by 50. So I'm going to have 15 pounds times 4 feet, then divided by 50 pounds, and that's going to be equal to dr, right? Alright, now let me slide this up just a little bit. Right? So now I have, let's see, 4 times 15, that's going to be 60, and that's pounds times feet divided by 50 pounds is going to be equal to dr. And then, so my pounds are going to cancel from the top and the bottom. And I'm going to have 6 divided by 5, which should be 1.2, right? 1.2. Feet, it's the units that's left, is what dr is. Okay, so I hope this helps you just a little bit see how to do some of these calculations. Okay, thanks.